So our last part for this section is about comparing the graphs. So if we have the function f of x equals 2x minus 1, and we want to sketch its inverse. So to find the inverse, remember, what do we do to find the inverse? We switch. So we end up with x equals 2y minus 1. So what would I end up with is my inverse? So we end up with x plus 1 over dose. That's my inverse, correct? Okay, so that means the slope is 1/2 and the y-intercept is at 1/2. Okay, when you graph an inverse, so when you end up graphing it, they should have a point that meets on the invisible y equals x line. Y'all see that green line? That's our y equals x line. If there isn't a point or an asymptote that crosses there, then your graph is incorrect, because they should meet or intersect on this line. All other points should be reflected across this line. So notice here, I'm at -1, 0, and its reflected point, 0, -1, is part of that graph. Do we see that? So all the points should be reflected across, and bam, you graphed. Okay, because it is online and your test will be online, you will be multiple choicing for most of them. But there may be ones where you have to sketch the line. Okay, when you're graphing a line using my math lab, you need 2 points. Okay, you got to use 2 points and pay attention to the coordinates at the top. That's wrong. You just said because you didn't use the correct coordinates. It looks exactly the same, but it's not. It's a fraction of a difference. Okay. All right. Any questions about graphing the inverses? None. All right. Next, just making sure we're comfortable with evaluating. So f of 2, using a graph to evaluate, what would be the answer for f of 2? -3. It took entirely too long for that, y'all. All you have to do is go to 2 and find it on the graph. Don't know what you were doing out here. It was a whole lot of work, I know, right? All right, now to find the inverse, we're gonna have to graph the inverse, okay? So graphing, to find the slope of it? I'm not sure what you're saying. All right, so we're gonna go over graphing it. Okay, so this is my line. These points need to be reflected over this line. So here's a point, here's a point, here's a point, and I'm going to reflect over. So if I'm currently at -1, +3, I'm going to be at 3, -1. Does that make sense? So there's my new home. If I'm currently at 0, 1, I'm going to be at 1, 0. If I'm currently at 1, -1, I'm going to be at -1, 1. Do we see that? And this one is currently at 2, -3, so I'm going to be at -3, 2. So, and that's a super straight line. That would be my inverse. Okay, so if I'm looking for -3 on the inverse, what do I get? 2. If I'm looking for +1 on the inverse, what do I get? 0. Okay. Oh, thank you, Zane. Now, could you do this without actually graphing the inverse? Yes, you would have to think about this. So if I'm looking for the inverse of -3, that means that I'm looking for when x equals -3. If I'm looking for the inverse at 1, I'm looking for when does the, in case you couldn't see, it's just super zoomed in for us. I'm looking for,
Pardon this interruption, teachers and students. We are now in a
All right, so that concludes 5.2. Any questions, comments, or concerns about 5.2? Nope. All right, so for the rest of the periods, you are encouraged to work on your 5.1 and 5.2 work for the week.